All right, let me hide this thing here. So let's begin our examples here today in our IDE, and you see that gradually I'll be visiting more and more our IntelliJ or any IDE here that we can work with the code examples, just because there's a lot of examples that we don't have in the lecture notes, and that means that I expect to more and more use those examples during class to go over some code, make sense of the code, and of course, like create the opportunity for us to discuss about the code that we have, right? So let's begin by taking a look at these monster and monster related classes here. Oh, actually, before that, I just want to comment on this spreadsheet here, right? So I'm not sure if I mentioned that with you, but this term, I kind of decided to move away from that memo format. So if you heard me talking about the very first day of lecture, I typically say that I go with these text files to record the topics that I would be covering, and also the thing that I intend to cover and so on, right? But I was trying to create this sort of historical pattern of the topics that I am covering, to have a sense of what to expect at each future week, right? Try to get a little bit more predictability in terms of that. So I am feeling that I'm not being as specific, as detailed as I was before, but you still have access to the previous one. So that's going to just be the same things that I covered in the past. And this last column here, you probably cannot read because this is super small, but this last column here is just giving you the high level topic and in which week this is expected to happen. Okay? Yeah. I am going to share that with you yet. I'm just finishing organizing here to make this into a little bit more easy to read format, because you see you have this very tiny text here, so I'm just trying to format it a little bit better, and then I can share that with you, okay? By the way, this is going to, at least that's my goal, slightly change. So maybe I would even refer to that as a more steady kind of planning for the weeks versus topics from now on, okay? Anyways, okay, that's, yeah, just if I don't share by the end of the day, just remind me, I'm gonna do that, okay? So let's go to our actual examples that we want to cover here today. So we have this monster class that if you observe the directory here, you see that we have flyer, monster, ogre, and phoenix and test monsters. Monster here is an abstract class, and you probably expect that to be a sort of super class or high level parent class of other classes, right? You're right if you're expecting that. So you have name and hit points as fields. If I scroll down here, I'm going to see a constructor of a monster, right? And maybe the first question I want to make you, if a class is abstract, that means that I cannot instantiate that class, correct? So why is it that I have a constructor in an abstract class?
So that passes all of the information down to its subclasses.
Yeah, the child class or the subclasses. So initially you might have the impression that this doesn't really make sense, but every time that you have a class that is not abstract, that inherits from an abstract class, So then there might be some initialization steps, some logic, some steps that needs to be performed by the parent class. So yeah, we do need a constructor in this case in our potentially abstract class, in this case, the abstract class. And this is just going to be executed same as any other constructor, right? That does not mean that I can go there and instantiate directly the monster class. That just means that every time that I have a subclass of that, and I call the constructor, then this constructor here is going to be executed beforehand, right? So we also mentioned that every time that you have a constructor of a given class, and that class inherits from some other class, so then even if you don't have any explicit call to a parent constructor, that's still going to happen. Java is still going to, under the hood, or implicitly do that, okay? So it's, in other words, fine for us to have a constructor on an abstract class. We have these abstract method here. Why is this method abstract? Maybe first, how do I know that this is a method and not a field? Syntax-wise. So there's a semicolon here, there's a name, there's some kind of type here. How do I differentiate that from a field? Syntax-wise. Is there? Yes. Is there a difference? Yes. The main difference here is going to be, so abstract could tell you that as well, but the main difference here is that a field doesn't take arguments, parameters, right? So that's an indication on the syntax of the method declaration. Yeah. No. That's also maybe a way to identify. Yeah. So void is kind of a type, but not really. It's more like a return type, right? You cannot assign void to a field, a variable. All right. And the abstract also, right? So if you have abstract, then you would be able to tell. If it's not abstract, that also means that you have an implementation. So you would see the curly braces and possibly something in between. So that's also one indication, okay? So this might seem like a silly question, but actually it took a while for us to respond that, right? Anyway, so this is an abstract method, and that means that I don't provide an implementation to that method. That also means that if I have a child and that child is concrete, what do I have to do? I need to implement that method. I need to provide implementation to that method. All right, so we do have one more method here, right, called getName. Is that an abstract one? No. Why? There's no abstract? Right. Just that would suffice, actually, for you to tell, right? Because you're in a class. So anytime that you have an abstract method in a class, there needs to be the abstract keyword. So here I have another one. This is a concrete method. Another one, right? And these are getters and setters, sort of, right? So get name is just returning the name field. Get hit points is just returning the hit points. So as you see, the fields are name and hit points. Right? So just getters and setters. So we do have one implemented method here, take damage. Can I, in an abstract class, can I provide an implemented method? Yeah, definitely can, right? Can I declare a method abstract in a concrete class? Nope, you cannot. Okay. All right, so this is an abstract class where I declare that take damage as a concrete method. Take some amount, so print something here, right? So I'll just look up the name, concatenate with that takes amount damage. Amount is also a field, right? Oh, sorry, amount is an argument that I receive here. Then I go and update my hit points. I subtract by amount. Then if hit points reach anything smaller or equals to 0, you are going to, actually, we would not need that equals, right? Smaller, if it is equals to 0, that's fine. But anyways, if hit points reach negative value, so then you want to reset that to 0, and then you want to print that message, right? So you're going to say that that given monster has vanquished. I didn't even know this word existed before seeing that example. I'm kidding, but that's an uncommon word. So we have the toString method that is called every time that you try to print a friendly, human friendly string to represent that instance of that class. So here I'm just gonna present that as a monster, curly, name equals, hit points equals, and so on, right? Just concatenating name and hit points. So pretty straightforward, right? So that's our parent class. You're gonna see that that's parent because if I open here the ogre subclass, you see that in the declaration it extends from monster. Right? So that's the indication that that's a subclass of monster. Same thing with Phoenix. So where's Phoenix here? So Phoenix also extends from monster. And we do have a test environment that I'm going to see in a bit, but let me go here to this flyer interface. So let's take a look at that flyer. I declare as interface. That's how you can tell that that's an interface. My fly interface has only one member declared. So what kind of member that is? So here it says public void fly, the name takes a parameter. It's an abstract method. An abstract method, right? So remember that with an interface, the methods, even without the abstract keyboard, would be implicitly abstract. Okay. What other types of methods can I have in an interface? Default, yes. What else? Private, static private, right? You can have a private method, right? So that's like a helper method to so for instance, for a default method, you can have a helper method, right? It cannot be public and concrete. So if it is public, as in here, right? By the way, even without the public, it would implicitly be public, right? Then it would need to be abstract, okay? So I have fly, that's a method that expects no return, public as most abstract method that you would see in an interface, and it takes distance, right? And does something related to that distance, right? Fly some length, whatever. So we saw that that interface was actually implemented by that Phoenix. Let's go with that Phoenix class first, then we can go back to Ogre, okay? So Phoenix, subclass from monster, and then implements flyer. If it implements flyer, that means that I am obligated to implement that fly method that we saw here. Correct? Yes. All right, so you can look up here. For the fly, you're going to see that the fly method, can you read? You're going to see that the fly method is the one that we are overriding that was specified by that interface as a requirement, okay? And maybe you should begin with that one to take a look at the implementation, right? So fly takes a distance, I print the name. So get name is just that same get name, but actually here, did we override? We did not. So that's just the same get name that we got from the parent. Concatenated with flies, concatenated with distance, which is the thing that I receive here as an argument, concatenated with that. So just a message that's saying some name flies by this given distance. Then I go and update distance flown, which is a field that I declared here. So that's a field that is declared in that particular class. And if you recall, Monster didn't really have any of those. It could have. I mean, if you would have a different business requirement, right? So you could have that field declared in a parent class, and you could, if that would not be private, you could go and manipulate that field, right? In that case, that's the same class. The own class is that making that declaration. So that's the field that we are just updating here. Just sum the current value by distance. Right? Any questions? Simple logic, right? Very simple logic. Just making some simple modifications to some updates to my fields, right? Putting things together, right? Let's go from the top and take a look at the implemented members. So declare the members. So I have a constructor here that takes a name and a number of hit points. Who can tell me what is this first line doing here? It's calling what? Calling the constructor of the parent class, which we saw before, right? Just sets those two fields, right? The fields have the same names, right? So that was the first thing that we saw here. Yeah. All right. So yeah. So we call that, set that, right? And then we go and set that field that is specific to that class, Phoenix class. Okay. So just set that to 0. We have an attack method. We also had an attack that was where is it? An abstract, was it? Yeah. We had this abstract attack method on our parent abstract class. So same as with the interface method, I do need to implement that in a subclass that I say that inherits from that class, right? So it's a similar requirement, obligation that I have to implement that attack. And I do that here, okay? So I print a message, some name, clause, the other name. So we receive here as a parameter, a monster instance M. If that's a monster, then I can have access to the name of the monster, right? Because those two fields have two getters, remember? And I can have access to any class that inherits from monster would be giving me access to those methods. The methods are already implemented by the abstract class itself, right? So that's how I know that I can use those methods, that I can invoke those methods. And then you have that thing there. Maybe someone can pronounce that, I cannot. And then you go and again, you use that reference of a monster to call take damage, right? So again, we can take a look at take damage and see that that's implemented here by my monster class. Okay. So if you are using IntelliJ and you are not sure how I got here so quickly, let me just show you that if you want to know about the declaration of that method, can just command click, and then this is going to take you directly to that implementation wherever that is, no matter what class that is. Right? So that's convenient. All right, so that's what we saw already. Yes. Get distance flown just returns that distance flown to string, so similar to that to string of the parent class, right? So I just override that, printing a nice message. Notice that here I add the information of the distance flow, right? And then I concatenate with the output of my parent to string implementation. That's one nice example of how to implement this kind of logic, right? Because I'm not just repeating the string that you would see on the parent. Instead, I'm directly calling that parent toString method. That's the way to go. That's good, because if I need to change that, I just have one single place that I'm going to go and change it, right? So I don't see code duplicated on different places. So that just makes my life easier, because I only have to change one single place, and then I don't incur into the frequent mistake of having to update many things in many different places, right? Make sense? So I have my fly method here. So fly was the one that we saw first, right? And then finally you have take damage. So take damage is one that we have overridden. So take damage is implemented here by our parent class. And notice that here we are calling that parent implementation first, right? And then we continue with our logic here, right? So if get hits, if the number of hit points is greater than 0, so you print that just to tell how many hit points you currently have. And here he also has this regeneration points thing, right? So that's, where's that? So this is a constant that we also have here that we skipped, but that's also a member of that class, right? So that's the way to learn gradually more about a class, right? So you go over line by line, you try to make sense of the members, the class declarations. You analyze what the declarations are stating, right? So you always ask yourself if you're looking at an abstract method, a concrete method, so on. So you need to make sense every time that you are looking at a method call, if that's a method that is implemented by its own class or a parent class, if you are overriding an abstract method that was declared in an interface or in an abstract parent class, right? So all that's part of your analysis, and all that helps you make sense of the business logic of the class, of the program, of all the classes, right? All right, so now we can go a little bit more quickly on Ogre. So Ogre extends from monster, so it's another subclass. I have a color field that is specific. Recall that a monster has name and hit points. So I just inherit those members as well. So here I also have a constructor that, same as with the Phoenix, calls the constructor of the parent class, right? Sets the color, which was something that was specific to the ogres. Ogres, how do I pronounce ogres? Ogres. Then I override attack, right? What's the difference here? Just the message here, I think, right? Then you take a given amount of damage here, right? So maybe a better practice here would actually set that as a constant and then just refer it by that constant. Again, toString, I make use of the parent toString, and then I concatenate with something else that is specific to the ogre. Right? Now let's take a look at these test environment here. I have a test class only with a main method, right? So if I just want to create a monster called Mike for whatever reason, so you set the name and the hit points, and then you have a monster. If you create a oh, sorry, this is the abstract class, right? So if I would actually try to do that, would that work? No. Why? Because you cannot create an instance of an abstract class. Right. So you go ahead and create an instance of called Fox of a Phoenix. So Phoenix is a concrete class, so I can go ahead and call that constructor. I pass those arguments there. Do the same thing with Shrek. Shrek is an ogre, whatever, and happens to be green and have 500 hit points. So you just do a series of attack calls, right? So you say that the Phoenix attacks the Shrek, and the Shrek attacks back the Phoenix, and then you print the Phoenix and the Shrek, and you break the line, and you keep going until either of those no longer has a positive number of hit points, right? Make sense? The current homework is going to be somehow related to this idea of simulation of heroes and animals and stuff. So it might relate to that. All right, let's move on to our second example here. Let me close these. So this is a way simpler one. I have only animal and cat, and the animal is most likely a parent class, right? Just by looking at a declaration of a class, you cannot tell which childs are going to inherit from that, right? So you need to go to the child and then see in the child declaration if you see the extends keyword. So that's how you tell how the inheritance tree looks like. So here I see that my cat class extends from animal. That's how I tell. Let's go back to animal. Let's see what we have here. So I have lives as a field. I have a constructor here that sets the number of lives. And I have a who am I method that is a concrete method. Why? Doesn't have the abstract keyword, right? By the way, a concrete class cannot have an abstract method. So that's a who am I? This is just a printing that message here. I'm an animal. Now let's take a look at the child, cat. So according to everybody, a cat has 7 lives. So that's how we said that here. That's our constructor that just calls the super constructor. And I cannot remember no more what that does. So that just sets the number of lives. Why am I set to 1? Whatever. Anyways, so I set that to 1. Then I have a main method that just creates an instance of a cat and then calls who am I, and who am I is this method here. I typically prefer to see the main method as the last method. I think it makes way more sense, easier to read. So who am I here is calling who am I from my parent class, which I need to look up to understand what that is, right? So it just prints I'm an animal. And then prints how many lives. The parent class. Oh, do I have more than one? We don't, right? Oh, we actually do, sorry. That was a hidden field. I didn't realize that. So we have lives here present on both classes, right? So that means that this one is hiding the other one, right? So that's why that super was called here. I didn't realize that. So yeah, so this is the parent lives, right? And then this is the cat's life, the child number of lives.